Now let's see what's going to happen. Let's quickly start. Okay, we are doing a read. Fair enough. This is C cell 1, C cell 2, so on and so forth. Let's presume that C cell initially, C cell 1 was written a 1 and we want to read this 1. Fair enough. So let's start our process. We know the way we start off with is this. Let's make a pre-charge 1. So when pre-charge is 1, both this NMOS transistors are on. So this is on. So this is a closed switch. So this point will get pre-charged to VDD by 2. So it will be the case at the bottom VDD by 2. So bit and the lower bit both are at VDD by 2. So when PC equal to 1, upper bit and lower bit both are equal to VDD by 2, or I can easily say that my A and B both are at VDD by 2. Now what's going to happen is I have made my word line 1 equal to 1. So this goes high. Remember, this is an output of a decoder. So all this are going to be low at that point of time. So all others are off. Word line 1 goes to high. That means this transistor turns on. And WL1 is high now. I'm drawing it here. This is on. There's a 1 written here. So it's a VDD present here. Voltage across this capacitor is VDD. And this is VDD by 2. We have already seen due to charge sharing what will happen is VDD by 2, because it's 1 is written, is going to go up by delta V. So this bit line or node A or line A goes up by delta V because we are trying to read a 1 at C cell 1. At the same time, this is off, this is off, this all C cells are off, so this will stay to VDD by 2. So the sense amplifier will have A as VDD by 2 plus delta V and B as VDD by 2. We know that this minute difference the sense amplifier will amplify, and what we will get is nothing but at bit we will get, yes, it's amplified, right? So what we'll get is at bit I will get VDD and at bit bar I'll get 0 because the small difference has been amplified by the sense amplifier. We have already seen it's working, correct? So now bit goes to VDD and bit bar goes to 0. That means this point now has gone to VDD and this has gone to 0. Remember, all these word lines are still off, so no changes are happening on their capacitor. No value is being written or no value is being read. Here, only this is on, all these are again off because this transistor is on still because word line is high and bit goes to VDD. That means now this VDD will be written on C cell 1 and C cell 1 now goes back to VDD. See, understand, a very interesting phenomena has just happened. What has happened is, because we wanted to read a 1 at C cell 1, my bit was at VDD by 2. So C cell 1, due to charge sharing, correct, this bit line went up by delta V, but this point went down due to charge sharing. So C cell 1 had gone down till the time both of them achieved the same value of the voltage. That means I technically lost this value. Now, when the sense amplifier amplified the signal, the word line was still high. So what it did was it went back and wrote this 1 to that location. That means while reading a particular location, the value tends to be lost by the memory cell. The value is written back by the sense amplifier, which amplifies the value of the signal, and the value is written back so that we don't lose out on the value. So this is nothing but rewriting back into the memory cell. So during the read operation, this rewriting keeps on happening.